Okay, I have a little confession to make. My desk can get a little messy. But I'm sure I'm not the only one. I've seen a lot of engineers whose workspace does not exactly look like the most organized place in the world. I think it's a side effect of the creative genius required for advanced problem solving. At least, that's what I keep telling myself. Creative genius. Yes. But when it comes to our hardware engineering projects, especially when we're working in a team, we need to keep our design data well organized. In the software world, this is accomplished with the help of version control systems. These awesome tools help manage every step of the design process, enable team design, manage versions and configurations, and keep our project from spiraling out of control. Like my desk might be right about now. Unfortunately, most of us don't learn version control for hardware design. Nope, EE classes don't tend to teach it, and most EDA companies don't provide support in our tools. Hi, I'm Amelia Dalton, host of Chalk Talk. Luckily, there's hope for implementing robust and effective version control for hardware design. My guest today is Ben Jordan of Altium, and Ben and I are going to explain how to implement effective version control, even for us hardware designers.
Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic.
Welcome, Ben. Thank you so much for joining me today.
Thanks for having me, Amelia.
So, Ben, I know we're going to be talking about version control in general, but can you tell us more specifically what we're going to be talking about today?
Sure. Version control is a really powerful set of practices, really, and also tools that enable those practices for managing data. But there's a lot of misconception, I believe, amongst hardware designers about what version control really means.
Okay.
I want to start by talking about, or answering the question really, what is version control? And also what needs a version control system should address, what problems it should attempt to solve if it's going to be implemented.
Great, okay.
And also I want to look at what the elements of a good version control system are. Really, what are the things that you need to say you have implemented a good VCS?
Fantastic.
And also how to use version control for hardware design documents, because it's usually been used in the past. Actually, for a long time it's been used by software development teams, but it's kind of something that hardware developers have been missing out on. And really they shouldn't have to miss out on it.
Absolutely not.
And finally, I want to basically talk about what you need to get started.
Okay, great. So we've all heard of version control, but it might help if we start with a more specific definition. What do you mean when you say version control?
That's a good question, and I guess I'll start by saying when I talk to a lot of electrical engineers and CAD draftspeople and PCB designers, a lot of them think of version control as some form of document control or document management. Maybe it involves a document revision numbering scheme where you put a specific revision on the title block of your schematic, for example, or you might even have a flat file system where you have a specific folder structure on a server and save all your schematic or PCB design documents to a particular drive, or even use filing cabinets with hard copies. And basically everything is given an ID and revisioned and given a specific revision number. We think of this as a form of version control. And really these fall into organizing your data and organizing your documents, but it's not really a version control system to do that.
Okay, so what are we trying to accomplish with version control? What needs are we looking to solve?
Looking at the history of version control systems actually originated from the software development world.
Ah, okay.
And as software has become more and more complex over the years, it became necessary to break up the process of designing and coding software products and making it much more scalable. So to do that, we needed to develop a modular design approach, which really is a form of design reuse. So software companies would form development teams and would break up their product into modules that would fit together and work together. And these may have been things like dynamic linked libraries or statically linked libraries and so on. Anyone who's done software development's fairly familiar with these processes.
Sure.
But this led to some really interesting challenges for software developers. Of course, compatibility of software libraries became an issue. If you wrote some code that used code from a library that somebody else wrote, and then they modified that library, it could break your code.
Ah, I see.
So there had to be some way of tracking versions and compatibility issues, and this really is also referred to often as dependencies, so there became dependency issues as well. And software engineering also became very much a team-based activity where multiple people would touch the same code. If you're working for a large software development organization, and you could be working on one module of code one day and the next week be asked to work on another project or another product altogether, and somebody else may take over where you left off, so they would start working in your code. So documentation is important.
Sure.
But the ability to keep track of all the changes and the work that different people have been doing is also very important.
Absolutely.
And engineering managers managing this whole process and managing the development cycle need a system where everything goes into one place and there's visibility into what their teams are doing.
Makes sense. Okay, Ben, can you break this down a little bit for us?
Sure. So really what this all boils down to is a version control system needs to address the following things. It needs to facilitate collaboration. Obviously, we're talking about team-based design here, and this has been going on for a long time in software already, as we know, but it's something a lot of hardware design firms and engineering teams are exploring a lot more these days to get things done on time.
Right.
We also need to keep an incremental history of the work that's been done and our sources in the version control system, because firstly it saves storage space, but more importantly it allows us to go back to any one point in time if we need to.
Ah, okay.
And this can also facilitate with traceability. It's increasingly important that engineering teams keep a track of the work that's been done against, for example, a traceability matrix or a specification for the product, so they can A, make sure they're on target for product development and release times, but also that they're meeting the requirements and not doing any extraneous work that's not necessary or not missing something that is necessary for the final product. So traceability is another important aspect of version control.
Makes sense.
And of course, on the tail end of that traceability and this whole teamwork concept, there needs to be reporting and monitoring capabilities so that development team can be managed effectively and that their code or design sources can be managed effectively and that reports can be generated to show that they're making the progress they need to be making. But one final and very important thing that's often overlooked, it brings accountability to the team. But we'll talk more about what accountability means later.
Okay, great. So I think I understand why we want and need to do version control. Can we walk through some of the mechanisms? Check in and check out is the most fundamental concept, right? Let's start with that.
You're right, Amelia. Every version control system has to have the basic check-in, check-out functionality. And what that really means is that we're able to store all of our design sources in a central, single location, so it's easy to get our hands on the data and also easy to back it up. But what this looks like typically is a developer can be working in their preferred IDE or text editor, or in our case it might be a CAD tool for doing the schematic or other electronics design functions. And from there you need to be able to check your sources into the version control repository, and any other time in the future you should be able to check those same sources back out again.
Ah, okay.
And this is not the same as really saving to a file share on a network drive, because there's a lot more metadata attached to the actual source files when we save them into a version control system. But more on that a bit later.
Okay, so you mentioned incremental history before. Explain that to us.
So how incremental history works is essentially you have some development start point for the project or for the given product that you're working on. And initially the developer or maybe the engineering manager will make the first check-in to a given repository folder or repository for that design. And that becomes, in this case, I've got an example, revision 0.
Oh, okay.
And that becomes the basic start point for all the code in the design. Anytime the developer makes a change or continues development work, makes updates to the source files and checks those in, it creates a new revision in the repository.
Okay.
But the cool thing there is it only keeps those changes incrementally, so it's not using a whole lot of extra hard disk space each time there's a new revision. It's not taking up the same amount of space all again.
Okay.
It's basically building incrementally on what was already there and just keeping the differences. But this also means you can get to any one of those revisions in future. So if you need to, you can check out a revision 1, even though the head revision may currently be revision 2. You can still check out revision 1 and look at the source files from revision 1 if you need to.
Okay, great. So if I've checked out something, how do I know if someone isn't messing with it at the same time?
That's a great question. And we mentioned earlier about version control systems facilitating collaboration. So naturally, you're going to have a system where multiple people can check out the same data.
Right.
So to get around this issue, version control systems support what's called locking. And this is where two different developers may check out the design sources from the repository. But let's say I'm the master developer and I'm working on the files and I know I'm going to make some changes to a given specific schematic or PCB document or C code file, whatever it is. I will put a lock on that in the repository so other users can see that it's locked and they won't mess with it, or they can see that it's locked and they can get a copy of it out of the repository, but they won't be able to check in any other changes until after I've checked in my changes and released the lock.
Ah, I see.
That means another user like John, who has the same source files checked out and has been working on them on his machine, his will be marked as dirty or out of date, and he'll know that he has to check out the current revision after I've finished and released the lock. He'll have to check out that revision and merge his changes in with that and check that back in. So this way it captures the work that everybody on the team's done and nobody's work is lost or overwritten.
Okay, so what if I'm working on a new version of a product and another engineer wants to make a change or a fix to the current production version? How do we handle that?
That's a great question, and the short answer is this is done by using a feature of the VCS called branching. But in your question you used the term what if, and that's what I like, because incremental history and check-in check-out lead to the natural ability and the desire to explore these alternative what-if scenarios and product variants. So branching is the way to do it. And basically how it works is this. For any project, there's typically one main line of development, and that will continue on over time. At some point, or some specific design milestone, you may decide to branch, and this is usually done when there's a product release or a development milestone has been reached. So you'll create a branch from that.
Ah, okay.
But you will continue on with the main line of development, and this can be done really easily whenever there's a release or a main development milestone. So you'll continue on over time, and each time maybe when there's a release you'll create a branch. Now the reason why you'd want to do that typically is that if you release version 1.0 of a product and it goes to production and it's out on the market, but you have version 2.0 constantly under development on the main line, but there may need to be some minor fixes or minor modifications done to 1.0 that really shouldn't affect the main line of development. So you would use a branch for that scenario. But the other side of this is that you may make changes on a branch that you want to keep in the main product as well for the next revision of it.
Right.
So the concept is to have a main line of development, but also you can have alternative lines of development, and then you may want to take features or development work that's been done on an alternative line of development and bring it back into the main line to include that new feature for the next main product release, for example. So this is typically used for exploring different methods or variants of the main design. It's also used for exploring different refactoring methods.
So what if we've been using this version control system for a while and there's a bunch of stuff in it, and we have to go back and do something to a particular older version of our design or our product? How do we find that older version?
That's a great question, and a similar concept to branching, which is called tagging, addresses that scenario. So basically what this means is you can make a tag, or it's sometimes called a cheap copy or milestone, of the particular revision that's of interest during the development cycle. When you make a commit to the repository for that revision, you can then actually take that revision and create what's called a tag, which basically means you put it in another folder in the version control system, but it's not copying or duplicating the data. It's really just making like a link to it, and that's given a specific name, and that makes it very easy to find down the road in future. So tagging is a very beneficial practice which allows you to specifically label different releases.
Okay.
It's kind of like this. You have your main line of development. Each time you make a release or a specific milestone, you make the copy or tag, and these go on with each different milestone or release that you produce along the way. So you can very easily get back to those in the system. You can browse to them. You can check them out to get access to the source code at that particular instant in time that it was tagged. And it's kind of like having the source code files, and for each of those specific release milestones, you essentially could put a label on it and say, this is a tagged release. So it makes it easy to find. That's just conceptually another way of understanding it.
So if version control allows multiple people to work on the same project at the same time, is there a way they can be working on the source files at the same time?
Absolutely, but this is where it's very important to have the right kind of development tools, because it's usually not an inherent feature of the version control system itself to do the comparison and merging of documents where multiple people are contributing to them.
Okay.
But this can be done, and there are tools for doing it. Of course, coming from the software world, all the design sources are ASCII text or, text code files anyway. So there have been many text comparison and merging tools around for a long time. For example, here's one, WinMerge, that I've used before. It's a decent open source comparison tool that lets you see where all the lines of source code have been modified, and you can merge changes from left to right or right to left. Now, of course, this doesn't work too well with a binary PCB or schematic document. So what we really want to be able to do is allow user A to check in a change. User B may check it out. They want to actually take the revision that they checked out of version control, make the changes locally, merge those in, and check it back in as a new revision. Now, if you work in a very linear way like that, it's very easy to do that, because you're basically working only with one copy of the file at a time. But the real interesting scenario happens when multiple people want to check out the same source document at the same time and work in different areas of it.
Right.
For example, different parts of a given printed circuit board design. One user may be working in the top left corner while another user is working in the bottom right corner. So text comparison and merge tools are fine, and it's easy to compare and merge text, but it's not so easy with the binary tools. So you need an effective ECAD comparator and merge capability. And this is really where your good quality electronics design tools are worth their salt. For example, in Altium Designer, there is a very powerful comparator engine that works from schematic to schematic, schematic to PCB, or between different revisions in version control of the same document. You can see here I've got this PCB design, and I'm comparing two different revisions of the same design, and you can see on the left the trace is unrouted, on the right that same net is routed, but the board shape is a bit different. So I can see multiple different changes. Now this is important, because even if we're talking about source code in software and comparing that, two different revisions of source code, it can still be kind of hard to see exactly where a different developer made some changes. But with hardware comparison like this, it's very clear what was changed, and you can go through the list of differences. You can see that big list on the left hand side there, and I can click on any change that's been made, and the system will clearly show me what's changed and highlight it. So that's very important to be able to keep track of the changes. And it's also to be able to merge changes where we want to keep work that somebody's done but maybe discard some other work that wasn't quite correct. So we can do that as well on the PCB tool, but we'll look at that a bit more later on.
Okay, now a lot of us have to deal with standards and certifications. It seems like version control can help us with that as well.
It sure can. Obviously, with complex product development, it's desirable to be able to keep track of changes, but really for meeting quality assurance, for complying to different certification standards like DO178B or DO254 and others, you have to be able to keep a record of every change to the sources for traceability. You need to also know who made the changes, and they need to be able to leave a comment as to why they made those changes, so that all the history of the design process is captured, and you can make sure that against the specification of the product or the requirements matrix, that basically you've addressed every need and you haven't put anything in the design that shouldn't be there, and you haven't left anything out of the design that should.
Ah, I see.
And also, another very important thing is this helps with collaboration, of course, but it also helps protect corporate intelligence. So if a developer leaves the organization, there's a good history of what they've done there, and you can very clearly see the changes to design documents that they've made. And accountability.
Uh-oh, I was worried that was coming.
Accountability is very important, but it's actually a little bit overlooked and misunderstood, because when I say accountability, naturally a lot of people think, well, they think about their manager watching over their shoulder, making sure they're clocking on at the right time.
Right.
But the truth is, what I really mean by this, and especially with version control, is it gives people real ownership of what they're doing. Because if I know I'm checking in source code or design files into a central repository that the rest of the members of my team have access to, they can see when I've made that change. They can see that it was me who made that change. And they can see the comments I've left in there, and they can also browse and explore the differences so they can see exactly the work that I've been doing. That's really powerful, because suddenly I care a whole lot more about the quality of what I'm doing.
Exactly.
So what we've actually noticed from more a sort of psychological point of view is that engineering teams who implement good version control practices immediately realize a productivity gain, and also, more importantly, a quality gain in what they're checking into version control. So everyone can see what everyone else is doing is what it boils down to.
Great. Okay, now Ben, in every project we have some kind of documentation. Most engineers really don't like this part. How can version control help us with documentation and reporting?
This is really important, because we want people to be able to spend more time innovating, more time being creative, more time actually getting on with the design, and not have to worry about keeping track of every little thing they've done. So one of the main benefits of a version control system is it does that for you. Basically, every time you've been working on some design or source files and you check those into the system, it's keeping a record of what you've done, and you can just type in a little comment there to say the reasons for the change or what you've checked in, and all of that is accessible, and you can generate reports from it with the right system. So this really facilitates project management. It helps with quality assurance. Obviously, as we mentioned earlier, it helps with standards compliance and the ability to get your designs and your products certified, if it's particularly if it's in the high-rel industry or aerospace, where you need to generate an output that says, okay, here's a specific change we made to the source files, and the reason we made that change is item 10 in the requirements matrix that said there shall be no dead code in the memory of the CPU, or whatever it happens to be. Every time you check in or make a tag or do a branch of the version control, you can keep some record of that and generate reports from that. So for example, here's access to a repository that I have some of my design files in. Using Tortoise, I'm able to go in there and look at the complete history of that repository. I can see all the different check-ins that were made by yours truly, the dates and times of those check-ins, and the messages that I typed in when I made those changes, For example, the highlighted item there is I'd updated a schematic document from a hardware design I was working on, and the comment was change title block text. So all of this information in the history or log of the version control system is accessible, and I can generate a report or an output from that for reporting purposes, among other things.
Very cool.
Also, we can generate graphical or visual reports. For example, this revision graph, and this is showing me each different revision for the specific file or project or folder that I'm interested in. In this case, it's a folder in my repository called Booster Buffer for a product I'm working on, and I can see it was initially checked in at version 11 of the repository. At version 35 of the repository, I created a branch from that, and that was checked in also at revision 37. And then I updated my main line of development at revision 38, which is the current revision of the repository. So there's also different graphs and other outputs you can generate that facilitate the management of the repository and the engineering process.
Okay, Ben, you've convinced me I need version control for my next project. What do I need to get started with version control?
To get started with version control, there are some really important practical considerations you need to think about first. For instance, and I mentioned this earlier too, electronics design obviously involves binary documents and files. So binary files can't easily be compared with a text editor or merged like C code can. So you have to have a set of tools that facilitates this kind of comparison and merging, as I mentioned before.
Okay.
Also, not every version control system is created equal. Some store source files in a flat folder structure, for example. This is fine, except you may run into problems if you need to store the same file but a different revision of it, because what it does is it would force you to change the file name, and that's not really convenient or conducive to a good workflow.
Right.
So you need to evaluate different version control systems very carefully and make sure they're going to do what you need them to do. Some others use a binary database, and you can basically put anything into them, and the structure is all based on database relational objects and tables. And some version control systems don't have all the features or functions or address all the needs that I've mentioned in this presentation. For example, branching and tagging may be a manual process with some certain version control systems. But the most important thing is your electronics design tool or ECAD tool must have powerful comparison and merging capabilities. So again, I mentioned before, in Altium Designer, there's a very powerful visual comparator that allows you to compare different revisions of the schematics and PCB documents. And you can also compare text files as well, or schematic to PCB, as you normally would for synchronizing your schematic design to your board layout. But the important thing here is also you get a very large list of all the changes that have been made, which you can see there on the left-hand side, and you can click on any one of those and it'll zoom to the change and highlight it for you so you can very clearly see what changes have been made. In the PCB editor, there's also very powerful merging and collaboration capabilities. So here, for example, you can see a particular complex board design has been divided up amongst a number of different layout designers, and in the foreground I'm working in a particular area where I'm making some changes, but other users I can see in the panel to the left, I can see different users who are concurrently working on the same PCB layout at the same time, working in different specific areas which are divided up into little squares, and we can very easily merge changes that have been made into one master PCB document, which then gets committed back to the version control system to become the new head revision. So this way we can actually have multiple people working physically on the same document at the same time to get the design done a lot quicker. And ideally, your ECAD tools should also have built-in version control capabilities. Again, I would recommend either Subversion or CVS because, first of all, Altium Designer has built-in clients for both of these version control systems and supports them basically out of the box. There's no real difficulty setting it up. It's very easy. Also, these are both open source, so it costs you nothing. Basically, you download it, you install it, you set it up. It's just a bit of time to get things set up. And also, very important, they're both very mature, robust, and very well supported. There's a lot of different people out there who have skills with these different version control systems, know how to set them up, know how to configure them. There's a lot of free documentation and how-tos on the web, how to set these up. I particularly like Subversion for particularly working with Altium Designer because it can run standalone on your own machine, or you can make it server-based. And there's a number of different options for setting it up as a server. You can run it as a service directly on a Windows or Linux server and have a connection over the network to that. You can also download different Subversion bundles from different open source communities like SlickSVN, CollabNet, UberSVN and Visual SVN are just some different examples where SVN comes bundled with a nice graphical user interface for configuring it and for configuring repositories and configuring repository users and groups. So it's really easy to get going with this. And one of the other great benefits is Subversion can run over a HTTPS, that is an encrypted web-based link. So that means you can actually install your Subversion repository on a cloud-based virtual machine. And this means you can get access to your data anywhere in the world. All you need is an internet connection and a login to your server, so only you can access your data or anyone else who you've given access to it to with an account.
Great. Well, thank you so much for joining me today, Ben. It was a pleasure speaking with you.
The pleasure's all mine.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.